Okay, so this we'll do a simple example here. How do we um, make this finite element model in Hypermesh and solve it in OptiStruct? So this is going to be a truss model. It just has truss elements. So here's the geometry shown here. So it's pretty straightforward. It has two different types of section. The purple are 1-inch square sections made out of aluminum. The blue lines are 3/4 inch diameter circular sections, also made out of aluminum. This node up here is fixed, and I don't know if you can see my mouse or not when I do this. Yeah, you can see my mouse. So the upper left node is fully fixed. The lower left node is allowed to move up and down in what you would probably call the Y direction. And we have two load cases. So the first load case will be a 1,000 pound force in the horizontal direction at that upper right node. And then the second load case will be two 500 pound forces acting down on the non-fixed nodes of the top spar, whatever you want to call that. Okay? So we'll have one material card. It'll be aluminum. Everything's made out of aluminum. Two property cards. One property for the 1-inch square section and another property for the 3/4 inch diameter circular section. Then 1, 2, 3, 4, 5, 6 C-rod elements that'll use one of the two properties. And two load cases. So we're going to make one load collector, one set that holds the SBCs, the displacement boundary conditions. That'll be used for both of these load cases. Then another load collector that'll have the 1,000 horizontal load. That'll be used in load case 1. And then a third load collector that'll have the two downward 500 pound forces. That'll be used in the second load collector. Okay? All right. So when you start HyperWorks, it should look something like this. Make sure you do HyperWorks and not, make sure you do Hypermesh and not HyperWorks. This is Hypermesh, even though up here it says HyperWorks. It's just a bug, but that's the way it's been forever. Okay, the first thing you're going to get is a user profile. If you've done this before, it might not show up, but probably you haven't. So you can pick the different solvers, but we're going to use OptiStruct, so make sure you have the OptiStruct button picked here. Once you have that, hit OK. If you do forget, you can always change it later, but let's get that right now. And here's the window we have. So here's the graphic window where you're going to see everything. On the left side, here's a model window that we'll use to kind of organize a lot of where everything goes. Down here's a window that's going to show input details like cards and whatnot. And then mostly I will use this lower panel button type of thing. Most of these also can be found here on the upper pull down, but I've just been doing this forever. This used to be the primary mode, so I still use it. But we have these different radio buttons that toggle those depending upon what you're trying to do. So if you're making geometry, most of those options will be in the geometry radio button. If you're going to make three-dimensional elements, you click the 3D thing. We're going to be making one-dimensional elements, so it will be in 1D and whatnot, okay? All right. So like I mentioned in class, we're going to do in this order of first defining the materials, then the properties, then the nodes and the elements. So like I said, there's one material here, it's aluminum. So we're going to do that, okay? So first I'm going to right click here and hit create material. Now when I do that, you'll see that we get options here that pop up. These are the input fields for the cards. So I'm going to call this aluminum, for lack of a more interesting word. We're just doing elastic, so different series of aluminums won't change Young's modulus super much, so we'll do that. And then in here, we will define Young's modulus and Poisson's ratio. Like I said, you need to define at least two. Well, you need to define exactly two. Don't define G, E, and nu. Define two of those, and it'll calculate the third. If you define all three, you will get an error. So it's we're going to be using inch, pound, seconds. So the units for Young's modulus are going to be psi. So it's 10 to the 6th psi. And then Poisson's ratio is 0.3. So there we go. And so now that card is here. And actually, if I right click on it, I can say card edit. And when you do that, you'll see it opens up this window that looks just like the Nastran input card deck thing. So this is useful sometimes, but it's also reproduced here on the left side. Okay, so we made the aluminum. Now we're going to define the two property cards. One property card for the aluminum 1-inch square section, and then another property card for the 3-inch circular section, 3-inch diameter circular section. All right. So let's first do the square section. So I'm going to again right click in this menu window and do create. And down here you'll see one, just like there was for materials, there's one for properties. So we're going to click on that. And this allows you to define all different properties for all different types of elements. So we give it a name. I'm going to call this square section. Okay. Now the card image. So we're going to not use a P shell card. That would be for shell elements. That's the property for shell elements. We want this to be a P rod card because we're going to do rod properties. And if we pull this down, you can see you will change that. Every time you do this, it gives you this window. I don't know why it asks you this. It's very concerned about you changing that, but so be it. So we're going to do that. And now you can see down here, we have the inputs for the cross-sectional area, the torsional stiffness, and the stress recovery factor. So for a square section, if it's 1 inch, I calculated these, right? Remember, for a square section, we have to use the effective ones, right? I probably should have made a slide with this, but you can go back in the notes and look at it. So remember the cross-sectional area is going to be 1 inch squared, right? So that's going to be 1. Now J effective, if you remember for the square section, is 0.141 times the area to the 4th power. Or not the area, the length of an edge. So that's 1 inch, so it's going to be 0.141 inches to the 4th. That's what's going to be for J. And again, the effective torsional stress recovery factor for a square section is 0.678 times the length of a side. So length of the side is 1 inch. So again, this is going to be 0.678. And now when I do that, now I have all, let's bring it back up. All those, the required properties like we talked about in class, defined for that section. Let's make a circular section. So I'm going to right click in here again and create another property. And I'm going to call it circular section. Oh, I missed one thing. It'll be good to show this in a second. Okay, I'll go back and fix it. So again, it's going to be a P-rod type of card. And the area for a circle, it's going to be just pi over 4 diameter squared. So that turns out to be 0.442 square inches. J, calculated the standard way, pi over 2 radius to the 4th, is 0.0311 inches to the 4th. And C is just going to be the radius. So if it's 0.75, the radius is 0.375 inches. Now what I forgot to do in the other one, and I'll do it here, is to specify the material. Because you most likely in most models have many different types of materials. In this case, we just have the one aluminum. But we got to tell which one to use. So we're going to click on that window, and it shows with aluminum, and we'll click that, and now the circular section is made out of aluminum, okay? I actually forgot to do that for the square section, so to do that, it's pretty easy. We're going to go back into this model thing and click on square section and go down to here where it says material, and we're going to set that to be aluminum as well. So now both sections, both P-rod cards use that material, the aluminum one, right? And like I said, if you had different materials, you could reference those by the properties, okay? If you have a square section and some of them use steel and some of them use aluminum, you'll actually have to define two different property cards for those, because one references the steel material and the other one will reference the aluminum material. Okay. All right, so we've got our material and our properties. We're ready here to start making our mesh. So it'll kind of default create one, but it's a good practice to create a component. So this is a Hypermesh type of concept. It's just like a layer or something. It's a way of organizing finite element things. So I'm going to create, and here you're going to see a component, and I'm going to call it a truss, because it has the truss stuff. And that's really all you have to do. For shells and solid elements, it will be important to identify the property. But actually, for one-dimensional elements, both truss elements and beam elements, it's going to ignore this field. It's going to use the actual property that's assigned when you create the element. And we'll see that in a second. So we'll leave that blank on there, but when we do shell elements, we will want to make sure that we use the right P-shell property for that, okay? Oh, so there we go. So we gave it a name, and that's it. All right. You'll note too, like a lot of times we'll have multiple components, and here you can see this font for truss is like boldface. So that means it's active. So when you create things, it'll go into that component level. If we had other ones, you could toggle between which one's active. If you right click on this, you'll see it says, oh, it doesn't. Okay, it doesn't say that. Look, okay, I'm gonna just for now. You don't have to do this, but I'll do it just to show you. I'm gonna make another component. It's called component 1, and you can see that one's active. But if we want to make truss 1 active, I'm gonna right click on it and select make current. Okay, so that's how you kind of toggle between those. But I really don't want this one, so I am going to delete it. There it is, delete. Yes. Okay. So we're good here. I'm going to save this now because I want to always save my work, in steps so I don't lose it. So I'm going to go and save this. I'm just going to put it into here. I'm going to call it truss 2. And so when you do this, it's going to save it as a .hm model. That's specific for Hypermesh. That's a Hypermesh model. Okay. You can see here it's shown. That's where it's saving it to, truss2.hm. Okay. So fine. So now we're in a position to start making the geometry. All right. So we're going to draw first the nodes, and then we're going to connect the nodes by constructing the elements. Okay. So let's do that. Now, the dimensions here are in feet, so we have to convert those to inches. So as we mentioned in class, there really aren't units in finite elements. You have to be consistent. So we're using inches as our length unit. So 4 feet becomes 48 inches, right? 3 feet becomes 36 inches. All right. So let's create the nodes, all right? So to do that, we're going to go into geometry. So I click this geometry button, and now you can see we get all things to create solids, surfaces, lines, temporary nodes, ribs, whatever. But we want to make nodes. So I'm going to click on this button here that says nodes. And now there's several different ways to input those. You can pick the center, put them at the center of a circle. You can put a certain number on a line, a certain number between 2 points, add an intersection between lines. But for us, we're just going to type in their XYZ coordinates. So I'm just going to hit this one here that says XYZ, and now I get like a window field that allows me to type in the coordinates. And boy, I hope you can see this. I wonder, let me just scoot this up. It might be off the screen just a little bit. Oh yeah, it's off the screen just a little bit. I think it is. Let me just make sure I get. Okay, there you should see the whole screen. I don't think there's anything we've done up to this point that causes an issue. All right, so I'm going to start typing in the coordinates. First, I'll put one at 0, 0, 0, and I'll create that. And you can see it put a little orange or yellowish tennis ball looking thing there. That's one of the nodes. I should mention you can move around and whatnot using the mouse buttons, and I forget what does what because I have a 3D mouse on this thing, but I think if you do Control and the left mouse button, you can rotate. If you do Control and the middle mouse button, you can do a zoom, and you make this little window and it zooms in. If you do Control and the scroll wheel, it'll zoom in and out, and then Control and the right mouse button, the third mouse button, it'll pan. Okay. Also, you can use these. So I'm going to look at like the default XY position. That's what it is. So you'll get used to it, right? You can also toggle them here. The next one, we're going to put the node that's 4 feet to the right of this. So that's going to be 48 inches in X, 4800. So I'm going to create that one. Now if we zoom using this thing to look at everything, you can see there it is. Now we have to do another one that is, another 4 feet. And so that's 96 inches. And up 3 feet from there, so that's 36 inches. And we're going to create that. Again, let's zoom out and look at everything. So that's the third node, and then we're going to come back with the fourth node, which will be at 48 inches and 36. And then the last one is going to be at 0.36. So, like, if you're going to model more complicated parts, obviously you're not going to type in the nodes by hand. This is handled in other ways. But for 1D stuff, we're going to do a lot just by doing it this way, okay? All right. So there's our nodes. And so now we're going to create the elements. And again, I've got the truss component current, so it's going to create them and put them in there. So to do that, maybe we'll save. It's always a good idea to save. So we're going to go click on the 1D radio button, and that gives us the menu options for creating these elements. So we are going to create rod elements. So we're going to click on that. And you have two options here. You can create or update. Updates, if you made them already, you want to edit them, but we're going to create them. Here, pick the two nodes that join them. And also, here's the property that it'll use. And here's the element type. So right now, you can see the element type is set to a C-weld. We haven't talked about that element, but that's not what we want to use. We want to use a C-rod element. So if I click here on element types, I get the options that make sense. And so here is C-rod. So I'm going to pick that. Now, if you had the user profile set to like Abacus, you wouldn't see C-rod. You'd see T3D2, right? Or something like that, okay? Now, let's first create the square section. So I'm going to change this property to square section. And so the ones that are square are the top and the bottom elements. Okay, so now I'm ready to create my first element. I'm going to pick this node, and it created it. Okay. Let's also do up here these two nodes. That'll create the second element and the third element. And so there we are. We're good there, right? Okay. Now, let's go back here and we'll create the other elements, but the other elements are going to use the round section. So I'm going to say in property to circular section. So now it's going to use those. And now we can create those. I'm going to do this one, and then this one, and then this one. And there we're good. So, you know, when you look at this, you can see they all look the same. So it's a little tricky. If you had hundreds of elements and they have different properties and different materials, this could be very easy to make a mistake. So a really useful feature is down here. This is a window that allows you to pick how you want, what you want the colors to represent as it shows it. So we could have it shade by the material. And so if I select that, you can see they all are blue because that corresponds to the aluminum material. We could also shade it by property. And so if I do that, now it's a nice way to check. You can see the top and the bottom elements use the yellow color because that means they're using the square section. And the other ones are cyan because that's the color that was assigned to the round section. Okay. All right. You don't have to do this, but I like to get rid of these temporary tennis balls. So I'll go to geometry and I will delete the temporary nodes. So you'll collect temp nodes and then just say clear all. And they just go away. I mean, they're just there for construction purposes. There's still Nastran grids there, nodes there, okay? All right, so we've got our geometry all done. The next thing to do will be to do the boundary conditions, okay? But I'm going to stop the video here, and then I'll pick that up in the second one. So I'm going to save this again and